first. And this was something we released about a year ago called DataDiscover. And so DataDiscover is about giving you visibility into your environment so that you can start to think about what are ways that I can optimize my environment better. And I like this little infographic because it seems to play out when I talk to a bunch of folks, which is, you know, what is the story around archiving? Well, the story around archiving is, hey, we're full, you ring the bell, you tell everybody to go clean up a bunch of stuff, a bunch of people run around, delete data, move it off into their disk drives on their desk, they go put it on thumb drives, they try to shove it in Dropbox, all these different things. And so the biggest challenges that we've seen is, one is that data is not readily available for reuse in an easy manner. And that two, the process yields little results to go free up space. And so you really end up in a world where you ring the bell and all of a sudden everybody runs and does stuff and you still end up buying a bunch more storage later. So this was part of the reason around DataDiscover, which was if we can make it really simple and easy for you to deploy a VM, you point it at all your file environments, we'll go give you a heat map dashboard into your environment. It really is as simple as that. It's not a project. It's not deploying a bunch of hardware. It is a VM that does all this scanning and aggregation of all metadata that applies the same kind of core components around adaptive scan and the infinite index to provide you with that visibility. The result of that is you can now start to take more surgical action to free up NAS. So this is the dashboard that we talk about. Is you can now see all your data that's aged, and what we age by is by directory or project. And so you can go and you can see in a given directory how much data is there, how many files are there, and you can see the age, and you can start to toggle the age on these directories to start looking for specific chunks or segments or projects of data. And we don't care whether it is, you know, petabytes, if it's hundreds of petabytes, whether it's hundreds of terabytes. It is the same view, it is the same refresh cycle. This data, you know, goes out, it scans fast, and you get your results on a weekly basis. And it does it all with disrupting what's going on behind the scenes. For most organizations, we scan all this data in under a day for them. And so it's very fast and lightweight to go use and deploy. Once you're at that space, you can go do one-click action to go archive your data. And so now you can use those economics of the cloud to go archive your data off, or you can use on-premises object or NFS targets to go archive your data. The biggest thing with archive is you probably weren't using it, probably nobody was touching it. So you're in an environment where, you know, archiving it off without stubbing is probably beneficial because you're going to keep your file counts lower and you're going to keep your operations of your primary NAS in better shape. But you're also going to gain the benefit of being able to search for that data once it's been archived. So you can go find it again on multiple dimensions to go search for that data. And you can restore exactly what you want. Do you want the whole thing or do you want just portions of it out? But it'll bring it back and restore it to wherever you want it to go.
Thanks, Christian. So we talked about the problems that people are facing and some of the things that Igneous does. So why would you choose us? We are really designed for HPC scale. We weren't a software product that was designed to handle small Windows file backups and then decided we were going to do HPC or decided we could handle multiple NAS and billions of files. We were designed from the beginning to scale to your capacity. As Christian said, whether it's a few hundred terabytes or a few hundred petabytes. And at the core are three technologies: adaptive scan, IntelliMove, and infinite index. These products uniformly scale in performance and capacity. They interface with your primary storage, and they provide a search interface so you can see what products you're backing up or what files you're backing up. Adaptive scan is the first core technology I'll talk about. And this is how we scan your file system metadata. This uses 75% fewer IOPS than Linux, and it can move data at line speed. Our numbers are around 400,000 files per second, and I'll talk about a customer example at the end, which is faster than any other product that I'm aware of. We have custom-built clients to attach to your NFS or SMB storage systems. And we connect directly to those shares. We're not mounting them. We're not running an agent on your servers. And we have multiple threads that dynamically allocate work, and those threads load balance as well. So if one thread completes, it can take work from another thread. There's also latency monitoring that scales up and down dynamically, which we talked about. We don't want to affect your user workloads. And there's no single task bottleneck.
And so, Adam, just I'm going back to that. Like, here was the reason why we did this. It was really important to go out and say, hey, we got to go scan through lots of data. And in order to go scan through lots of data, I can't mount file systems and go through a kernel. That is really, one, requires a lot of IOPS and work. It also requires a lot of CPU to go do it on whatever you're deploying. This is why we can deploy through VMs, is because we wrote our own, call it NFS Lite or SMB Lite connection. And then the other thing is what bogs people down, you know, if you're thinking about this from an rsync perspective, if it's doing an rsync and just doing a tree walk, is the imbalance associated with file systems. A lot of those technologies are hard bound to a directory path. And so even in the best ways where you try to distribute that movement of rsync and run multiple at a time, you're still going to be in that mode where the longest running or the deepest tree is going to take the longest amount of time. And so by having this dynamic reallocation, we can just keep churning through file systems at a speed so that, you know, it doesn't matter whether you're in a deep one or a shallow one, it all finishes predictably across all your environment without you having to actually think about how it gets distributed across that environment. So you want to talk about the next one, Adam?
Sure. IntelliMove. So IntelliMove is what actually moves the files. So this is highly parallelized. We compress the files. Again, it's latency aware and optimized for massive unstructured data. There's a native API for certain NAS and cloud vendors. Well, native API for all the major cloud vendors. But from your network attached storage, we can certainly work with any generic NFS or SMB if your API is not supported by us. And again, it's very similar technology background, custom built clients, multiple threads, dynamically allocate work. We are prepared to handle mixed files of different sizes and amounts. We're not something that fails on small files or fails on large files. We were designed to handle any kind of mix. And the same latency monitoring and no system bottlenecks, as we mentioned before.
Yeah, and so on this one, if you think about the scan part of it is when you go out and you find data and you want to move it around, you got to go then find data, you want to then go move it around. So this is the next set of thread pools that do the work for actually moving data. And again, back to that, I don't want to create a mountable through a kernel data mover, but the real goal here is to pipeline the data movement activity as much as possible. And so when you're talking about, I have to read data, I have to aggregate data, I have to compress data, and then I have to push that data off. And I've got big files and small files. And so ultimately what it becomes is this pipeline activity and keeping a lot of data in movement at all times. And whether you're talking about small files or big files, you know, we've done it all. We have environments that are, you know, several petabytes, but are 100 billion files. We have environments that are several petabytes and there are hundreds of millions of files. And so you've got to be aware of how you can handle each one of those types of environments dynamically without having to do a bunch of customized tuning. The result of that is we just keep data moving. Like you keep it up in the air, you keep it in a pipeline from coming off the system to pushing it through. And then the biggest thing of this is that when you're moving data is probably the most impactful to, you know, impacting latency on source systems. And so we're always monitoring that latency of that source system so that when applications are running, because when you're moving, you know, a couple hundred terabytes of data, it's going to take a while. It's not going to all happen, you know, shortly. So chances are you're bleeding into the hours when people are actually doing work. You know, we're going to scale back the number of threads that we're using to do work as that latency pops up. And then in those kind of off cycles, we're going to go scale back up again. And so you don't have to think about, you know, do I have to tune this daily, hourly, minute, etc. We just take care of that for you.
Finally, our third core technology is the infinite index. So I had mentioned this earlier, but this is our global scalable metadata index. It is our own custom data structure. As I mentioned, you don't have to install a relational database, and we're not backed by something like that, because those types of technologies fall apart at the scale of HPC. You can throw hardware at them for a while and you'll get some level of performance, but once you get to the level that most of your organizations are at, they simply won't perform at the rate that your data is being generated. And our index is decoupled from compute. We don't burn a ton of compute cycles as we're writing this index. It supports billions of entries and high insertion and query rates. And we can support multi-dimensional queries as well.
So the index to us was the critical part of this, which is when you start talking about, backup and archiving data, the difference between just replication and backup and archive is the index that goes with it, so that you can keep track of versions and histories, and you can search through it, and you can create views that are like the DataDiscover view that we show off that index. It turns out indexes are historically driven off of regular databases, and they don't have the scale to handle hundreds of billions to trillions of requests. And so you've got to do a lot to both minimize the footprint of your index. Like, I don't want to deploy a whole bunch of storage and servers to go store my index. And you got to do it in a way that has the queries you want to ask already predefined in it. And so, our index is the counter snapshot to finding change in file system. Our index is the view that you see from DataDiscover. Our index is the search over ad hoc queries to go find data that you want to restore. And it's really built around this concept of something you have to build yourself to do it to maximize the efficiency at scale. And so that is why we built the index the way we did. And it's really those three pieces of the move capabilities, the scan capabilities, the index capabilities that work together to offer our archive, our DataDiscover, our DataProtect in the ways that you want to use it in your environment.
Thanks, Christian. So a short customer example about real-world performance. This was a customer HPC environment. They have petabytes of engineering data, and total capacity was about 8 petabytes with 19 billion files. We were able to scan this in 14 hours, which works out to about 378,000 files per second. And just a little bit of details about the systems. That was Isilon and Pure FlashBlade. It was a heterogeneous mix. So we're really designed to be deployed in these environments and just get up and running and get you answers very quickly. Go ahead.
To say, so, we shoot for, on our DataDiscover stuff, to have you a fresh view of your data every week and get it done, before the Monday hour rolls around. The good news is we hit that quite a bit, and we have really cool stats about what does it look like in an average environment. Like, an average environment has 50% of its data hasn't been touched in over a year, if not 2. An average environment is 6 petabytes with 3 billion files in it. An average environment, can get up and running and get scanning and produce results in as little as a few minutes once this starts. And so really it's that visibility portion of it, but it's also plays to the, when I'm going through and I'm scanning for change rate, these numbers hold up. These are the type of numbers that you would start to see when you're doing DataProtect, when you're doing your level 0 incremental forever type of model. So we really like to pride ourselves on being fast and being simple and being easy to go use and deploy, and not require a lot of infrastructure deployment, management, or oversight.
Thanks. And that concludes our presentation. We're here for